Hello everyone. In this video, I'm going to revisit a topic that was covered very early in the series, strings. But this time, I'm going to go into more detail on some of the things we can do with strings. The reason I didn't do this back then was because when I first started talking about strings, I was also talking about the other data types. So I wanted to make sure I could cover all the data types without making the video too long. So my plan was always to make this a separate video. Which leads us to B. I was so busy covering all the other topics that I just completely forgot. But we are finally here now, so let's get started. Real quick, let's review what a string is. A string is a sequence of characters enclosed in quotes, whether single or double. They can be used to represent textual information such as names, sentences, messages, and stuff, but they can also be used to access information in a data structure like a dictionary. Strings are immutable, which means that once they are created, they cannot be modified. In order to make changes to an existing string, you actually have to create a new string from that existing string containing the changes that you want made. Now with that review out of the way, let's go ahead and dive into the first example. So for the first example, I have a variable called name and it's equal to the string Crozo. First thing I do is just to print it out so you can see it printed on the screen. And then the next thing I do is I check the length of the string. Knowing the length of your string is very important, especially if you might be dealing with a bunch of strings of varying sizes. You want to make sure that when you're trying to access certain indexes of that string that you don't go out of bounds, which can cause errors. And then after I print out the length, the next several print statements is just basically me showing you how to do all different types of indexing. There's a lot of cool things you can do with indexing. There's a lot of neat tricks with Python, so I'm just going to walk you through them. The first one is pretty basic. We're just accessing an individual character in the string. In this case, we're accessing the capital K in the name because like a list, when you're indexing a string, you always start with 0, which means that when you want to access the last character of the string, then you're not accessing index of 6 because you see 6 characters, you're actually accessing index of 5 because it starts from 0 to 5. And then in this next one, I'm accessing a range of 0:4, basically from character at index of 0 up to character of index of 3, because this range will not include the second number. So we will go up to 4, but not including 4. So when this prints out, we'll see crow. And then this one right here is basically the same as 0 to 4. We're just not specifying 0 to 4. So we're saying print out all the characters up to index of 4, not including 4. And when we put the colon on the other side, we're basically saying starting with this index, print up all the characters up to the other index, which in this case, since we don't specify another number, it's just basically going to print out the rest of the string starting at index of 4. And we can use negative numbers for indexing as well. It basically just means start from the end of the string and go backwards. So :-2 is basically going to be the same as saying :4 or 0:4. It's going to print everything up to index of 4, not including index of 4. Whereas where we put the colon after the -2, it's basically the same as saying 4 then colon. It's going to print out SO. Now double colons have a bit of a different effect. Double colons followed by a number is basically going to say print out every X character starting at index of 0. So ::2 is going to print out every other character starting with index of 0. So when this prints out, we're going to see K, O, then S. And then if we specify a number before the double colons, that's basically saying starting at this index, print out every X character. So when we print this onto the screen, it's going to start at R, then print W, and then print O. And this line right here is basically the same thing, but we're printing out every other character starting at index of 2. When we specify negative numbers with a double colon, it causes it to print the string in reverse. So ::(-1) will basically just print the whole string out in reverse. So we'll see OSWORK printed out in that order. When we specify a number before the double colons and followed by a negative number afterwards, it's going to reference the index of the original string, which in this case, the index of the string is O, and then print out the numbers in reverse from there. So it's going to cut out the OSW and only print out the ORK. And then this down here is just basically demonstrating that everything up here is returning a string, so you can store the results of this index slicing into another variable. So we'll go ahead and run the example. Name Crozo, length of the name is 6. We access the index of 0, which is a capital K. 0 through 4 is KROW. Index :4, that's still crow. Index 4 : that's SO. Index -2, we're basically counting up to the character here, not including this character, so it's still crow. -2 colon SO, colon 2, counting every other character, so KOS. Counting every other character starting at index of 1, we get RWO. Counting every other character starting at index of 2, we just get OS. Double colon of a negative number, we basically print out the characters in reverse, so we get OSWork. And then a number followed by a double colon followed by a negative number. We access the index of the string first, and then we print it out in reverse because of the negative number. And then I store the reverse indexing into a new variable and I print it out, which is what you're seeing down here. So that's indexing and slicing with strings. Next up, we're going to talk about casting. When strings only have numerical characters in them, we can actually convert them into an integer or into a float if it also contains a decimal point. In the first part of this example, I take a string containing the number 22 and I print out its type as it is right now. So it's going to print out type string. Then I cast a string as an integer and store the new integer 22 into a new variable. And then I print out the type of that new variable. So it should print out integer. But basic numerical casting is not the only thing we can do. If we have strings that contain characters for specific numerical representations, such as binary, octal, and hexadecimal, we can use integer casting to take those strings and convert them into their proper base 10 values by specifying the base that they're currently in. So I've got a binary, an octal, and a hexadecimal string right here. Binaries only consist of ones and zeros. Octals can be from 0 to 7, and hexadecimals are from 0 to 9 and A to F. A to F representing 10 to 15. So when we want to cast these numerical representations into base 10 or decimal, we have to add an extra argument into the integer function when we're casting. So for binary, when we put the binary string in, we follow it up with a comma, and then we put in the number 2. This will tell the integer object that we are converting a string that is in binary representation. Same thing with octal, we specify 8. And with hexadecimal, we specify 16. So when these strings print out, we'll print out the original string followed by their base 10 values. And then finally, when working with individual characters, we can get their numerical codes, or we can take a numerical number and convert it into its character counterpart, provided it's valid numerical code. So down here, I have a character code 65 and I have a character capital X. So for the character code, I pass it into the function character, CHR, and that will return the ASCII character if it exists and print it onto the screen. For our character, we pass it into a function ORD, and that will return the numerical value for that character. So go ahead and run it. So our num string, type string, and then when we cast it into a integer and store it in num, and we check the type of num, it's an integer. The decimal conversion of a binary string 1011, that is 11. The decimal conversion of the octal string 456, that's 521. And the decimal conversion of a hex string F9 is 4113. And then as you can see, our character code 65 is equal to capital A, and the decimal code for the character X is 88. Our third example is a sort of semi-review of operators and certain expressions that we can use with strings. The first one was actually covered in the initial data types video, where we can use the plus sign and the multiplication sign to interact with strings. The plus sign is concatenation. It will combine two strings together into one string. The multiplication sign will basically cause a string to repeat a certain number of times. Then we've got some of our conditional operators, equals equals and not equals, which will basically evaluate the actual values of the variables and see if they're equal to each other. So string 1 equals to string 2 will return 2 because they're both equal to the same value, 3 lowercase a's. String 1 not equals to string 3 will also return true because 3 lowercase a's is not the same as 3 uppercase a's. The next one is a bit weird, and I've never actually really seen any working examples of where this would be used, but if it's in Python, then there clearly is a use for it. And that is using the greater than and less than signs. And of course, there's the greater than equals to and less than equals to signs as well, but I'm not really going to include this in here because it's pretty much the same thing. It's just with the added clause that if they're equal to each other, then return true. So for these two symbols, what's happening is it's evaluating the ASCII decimal number of each character in a string. And the way it works is when given two strings, it will evaluate the character on each index. So Index of 0 for both strings will be evaluated to each other. Index of 1 of both strings will be evaluated to each other, and so on and so on. It's not going to evaluate the index of 0 in one string to the index of 1 in another string. When evaluating the characters at a given index of both strings, the string that has a character in the index that has a higher value of the character in the other string at that same index will be considered the greater string. So when we compare string 1 to string 3 and we're checking to see if string 1 is greater than string 3, it's going to return true, because lowercase letters actually appear later down the ASCII table than uppercase letters. So a lowercase a has a higher decimal number than the uppercase a. Likewise, when we compare string 1 against string 4, it is also going to return true, because a lowercase b has a higher number than a lowercase a. Now, when we use reserved words in and not in, we're basically saying, is this string contained within this string? And in this example, for the first one, I say, is string 1 in string 5? Which, as you can see up here, that's the case. The three lowercase a's are contained within string 5. So string 1 in string 5 will evaluate to true. When we say string 3 not in string 5, we're basically saying, does string 5 not have this? Pretty straightforward. And since string 5 does not have three capital A's, then this will evaluate to true as well. Now, the is keyword is a bit tricky because it does tend to confuse a lot of people on what it's actually evaluating. They often confuse it with the equals equals and the not equals. What the keyword is does is that it evaluates the memory address that the data is stored in. Because string 1 and string 2 in this program are in the same scope and they're pointing to the same value, Python will have both these variables point to the same memory address that contains the string value 3 lowercase a's. So when I say string 1 is string 2, it's going to return true because they're both pointing to the same memory address. When I say string 1 is not string 3, that's going to of course return true as well because string 3 is pointing to a completely different value, therefore it's going to be referring to a completely different memory address. And just to show that, I'm using the ID function here to print out the memory addresses of these variables. You don't often use the is keyword in this sense. I'm not saying you can't, you can obviously, but most of the time you're not using it in this sense. You're often using it to check to see if a variable is of a certain type. And the reason this works is because when Python runs, every type is an object. Class is an object in Python. Integer is an object in Python. String is an object in Python. So we can say, is type str1 the same as string? Type is going to return the type of string 1, which in this case is a string. So what this expression is basically saying is string, which is true. And to prove that, I call type of string 1 and I pass it into ID, and then I pass the string object into ID as well. So we're going to see the same ID print out twice. So I'm going to run the example. So we see our concatenation example here and our multiplication example here. So string 1 plus string 3, that's what we get here. And then string 1 times 5, that's what we get here. Then we see our evaluations here. So string 1 is equal to string 2 because they have the same value. That's true. String 1 is not equal to string 3 because string 1 is lowercase a's and string 3 is uppercase a's. That's also true. We then see that string 1 is greater than string 3. That is true because lowercase a's have a higher decimal number on the ASCII table than the uppercase a's. So it prints out true. Likewise with string 1 lesser than string 4, that is also true because lowercase b has a higher decimal number than a lowercase a. String 1 and string 5. String 5 contained 3 lowercase a's and string 1 is just 3 lowercase a's. So that evaluates to true. String 3 not in string 5. String 5 does not have 3 uppercase a's. So that evaluates to true. String 1 is string 2. They both contain the same value in the same scope, so they are likely pointing to the same value in memory and therefore are referencing the same memory address. So that is true. String 1 is not string 3. They are pointing to different values and therefore they are referencing different memory addresses. So that is also true. And then to prove that, I print out their memory addresses using the ID function. So string 1 and string 2 have the exact same memory address number, and then string 3 has one that's completely different. And then for the example where we demonstrate how you would normally use the is keyword, we're basically seeing if a variable type is the same as a type. And this of course evaluates to true. And then we print out the memory address numbers of the type of string as well as just the string object itself. And as you can see, they come out the same. So that's how the is keyword works. For this next example, I'm going to demonstrate the split and join functions that we can use on strings. The split function allows us to split a string by a specified character into a list. In this example here, I split the message by the space character, so I'll get a list containing all the words. It does not include the characters that we split the string by. If you call a split function with just a blank string, meaning no space, it's just two quotes together, it will split it by each and every single character, including the spaces. So I print out the message, then I split it by the space character, and then I print out the new message, which will basically print out a list. The join function is the opposite of the split function. It allows us to join a list of values together into a single string using a specified separator. So in this example here, I take the message that we created and then I add a few other words to that list. Then I call the join function. Now the way the join function works for our list and our separator is a bit different than it is for split. We don't say variable containing the list dot join, and inside of join we specify the separator. We actually say the separator dot join, and then we pass the list into the join function, which is what you can see here. So my separator is going to be a single space, which I indicate with two single quotes and a space in between it, dot join, and then I pass the message variable into the join function. And then we store that back into our message variable, and then I print out the new message. So I'm going to go ahead and run our example here. So here's our original message. This is a message to all pilots, as you can see here. Then here it is in the list form after we split it. And then here's the message after we added 3 new words to the list and then joining the list back together into a string. Now this next example, I'm going to show a few functions that help you remove stuff from a string or replace certain characters or even whole words from a string. So I've got this message here that is a jumbled mess because it's got all these characters and stuff in it. You can sort of make out what it's saying. It's saying this is a garbled message. So the first 2 functions we're going to look at are lstrip and rstrip. The way these 2 functions work is that lstrip will look at the beginning of the string and strip out any characters it can find starting from index of 0. Whereas rstrip will go to the end of the string and strip out any characters it finds from there. And then we have the strip function, which is basically the L and rstrip combined. It will look on both sides of the string and strip any occurrence of the characters that we pass in. The first occurrence of strip will strip out the pipes, so we'll get rid of both pipes. Strip pipe T will remove the pipe T here, but it will just remove the pipe here. So even though we don't have a pipe T on this end, it did see that there was a pipe there first, so it will still strip it. And then our replace function here is going to remove all of the periods. When we specify an empty string, no space or anything like that, it basically just removes it from the string. And then this last part here is basically showing that you can chain these functions together because all of these functions return strings as a result. So that returned string can then call upon the next function in line, and then the function will do its thing and then return a new string from there. And it'll keep going until it reaches the very end. In fact, if I wanted to, after calling all of these, at the very end, I could have added a split function and split it by the space character so we get a list of words. So basically what this whole chain is going to do is remove both pipes, remove all of the periods, replace all the hyphens with spaces, and then replace the word garbled with ungarbled. And then it will store the result into new message 2, and then I print out new message 2. So I'm going to run the program. And so for the first line, lstrip removes the pipe here. For the second line, it removes the pipe at the end. Strip will remove both pipes. And then for this strip right here, where we say strip pipe T, you can see that the pipe T is removed at the beginning. But even though there's no T at the end of the string, it still removes the pipe at the end. And then the replace period with blank string, that removes all the periods from this one, so it looks more intelligible. And then the final line here, this is where we basically did everything all at once, stored it into a variable, and then printed it out. So now it's an ungarbled message versus a garbled message. This next example is pretty simple. Given a string, we can convert the case of each character in a string. The upper function allows us to turn all characters into uppercase. The lower function will turn all characters to lowercase, and the title function will convert the first character to uppercase and all the other characters to lowercase. These functions will work on strings that contain numbers and special characters. They will simply ignore them and continue looking for other alphabetic characters. So I'm going to go ahead and run this example here. So we have our original string here where I have a capital R and capital S and the rest are lowercase. Then upper converts it to all uppercase, lower converts it to all lowercase, and then title just capitalizes the K and turns everything else to lowercase. For this example, we're going to look at what I like to call is functions. I'm sure I'm not the only one who calls them that, but that is just what I call them because it's just easier to reference them as a whole. Is functions are basically functions that check to see if an object is something. These functions are typically used in conditionals such as if statements or while loops. For string objects, there's a number of is functions, but I'm only covering typically the most common ones. There are a handful of others, and I'm sure there's a bunch of people who use them, but I'm just covering the ones that you're most likely going to hear about. The first one is alnum, which is short for alphanumeric. It basically checks to see if a string only contains alpha and numeric characters. It basically returns true if a string only contains alphabetic characters or numeric characters. No special characters or spaces. Is alpha, which obviously is short for is alphabetic, checks to see if it's a string that contains alphabetic characters only. If it contains numbers, special characters, or spaces, it will return false. Is digit checks for numbers. Is digit will allow decimal points for floats as well as superscript and subscript. And then is upper and is lower will check to see if the specified string object is all upper or all lowercase. All of these is functions can be used on an entire string or on a specific index within that string. So the first one is going to return true because string 1 has both alphabetic and numeric characters. Is alpha is going to return true for string 2 because it's just a word, well technically a name, but it's all alphabetic characters only. Is digit will return true because it's just a bunch of numbers. And then we look at string 2 index of 0, which is k, to see if it's upper, that will return true. And then we look at string 2 index of 1, which is a lowercase r, and we check to see if that's lower, which will return true. So I'm going to run the example, and everything is true. And for our final example, I'm going to show you a few functions that we can use to search our strings for certain substrings. So I've got two messages here, one that lists a bunch of semicolon separated ships, and then I have another string here that will just list one ship. For the first string, I have count, find, and index. Count will count the number of instances that a specified string shows up in a larger string. Find will search a string for the first instance of a specified substring. Index will do the same thing, except it will return an error if it cannot find it. And then for our second string, I show two functions startswith and endswith. Startswith will return true if a string begins with the specified substring, and endswith will return true if the string ends with the specified substring. So when I run this, so for the first set here, we get the number 3 because the word ship shows up 3 times in this string. Then for find, we get 14 because at index of 14 is where cruiser starts. And then for index, we get 28 because that's where capital starts in the string. And then for the second string, startswith returns true, as you see here, because the string does start with FRI. And endswith returns true because it ends with hip, as you can see here. And that's about it for all the advanced stuff that we can do with strings in Python. There's still some other functions and other things you can do with strings that I didn't cover in this video, but the things I did cover are the most common advanced stuff that you would do with strings. So I hope you've enjoyed the video and found it helpful, and if you did, be sure to hit the like button and leave a comment below to let me know what you think. And if you want to see more, head on over to the Wayfair Coding Academy channel to check out my other content. And while you're there, consider subscribing to the channel to stay up to date as new stuff comes out. Thanks for watching, and I'll see you all next time.